Hello everyone, welcome to this new playlist on mechanics. Mechanics comes as first chapter typically in an undergraduate syllabus, that is in BSc first year. And what I'm going to cover in this video typically appears on the first page of that first lesson. So I'll be aiming to do three things in this visualization. Visualize a simple motion on a line, which is typically referred to as a one-dimensional motion. And as a result of that, towards the end, I try to convince you what are the parameters needed to describe the motion. And the third one, to explain the visualization interface that will be used not only for this video, but many videos which are going to cover mechanics. To start with, for the motion, we need to have a particle. So let's say this is a particle. It's a representation of a particle. Typically, we put a small dot in textbooks to indicate the particle. Here I have magnified it just for clarity. The object can be present anywhere. So given a space constraint on the screen, it can be from this point to this point. Now there are two things which we should remember. When the object is present here, the object could be in motion already, and we have decided to observe it from this point, or the object is stationary at this point and it starts at this point. So for this visualization, I'll be assuming that the particle was at rest and it starts its motion from that point. So the inherent in what we are saying, either the particle is present left or right, it demands a reference point. That is, with respect to some reference, we have to say where the particle is present. For example, this first controls over here can help us decide to place the particle at the desired position. So first let us see the reference. So the reference can be anywhere. The reference can be anywhere, and for the sake of simplicity, I have put it here. It is right in the middle of this stretch. So it can be present on the right side or it can be present on the left side. And the slider over here helps us to place the particle at desired position. If I put it at the maximum and if the selection is left, it will be present over here. And if it's maximum and the selection is right, it will be present here, the maximum permissible value in this visualization, or any intermediate position on the right or on the left. Also, there is a color scheme which I would like to introduce in this video itself, so which will be helpful in future videos. Though the color scheme may not be so relevant, it may not appear relevant in most of the context, but anyway, I'll be using it. It will be used in future videos to come. So this particular line over here, the central line, will glow blue if the particle is on the left side, and if it will glow red when the particle is on the red. Even the motion is happening, the color will change as the motion occurs. Now the motion, as the term indicates, the particle changes its position. It is here, and next moment of time, it can be either here or here. That means it can move either towards right or left. Now we have controls over here, which will help us decide that. First, let us see that. For example, the selection is right and the object moves towards the right, or the object can move towards the left. So you could see this color is blue because the object is present on the left side of the reference. And also there's a color scheme for which side it is moving, where it is present and which side it is moving. For example, if it is moved towards the right, let's put it right all the way on the left side, and you observe the color. This particular thing is for the color demonstration. So it is present on the left, so this line will be blue, and it is moving towards the right. A dot will appear here which will be in red in color, blue, and it has become red. Look at this dot. And also this slider will help us to decide how it is moving. That is it moving fast or is it moving slow? Now this is slow compared to the earlier one. Now you can see this red dot means the object is moving towards right, and it is this line indicates it is moving on the right side of the reference. So this we can make object move left. So for that, let us put the object somewhere on the right side and let it move. So the information over here is also converted into text here. So in the beginning, like this is the start of our motion. In the beginning, the object is on the right side of the reference and it will move towards the left. Now let us see. The dot will be blue. You can see the blue dot and change over the curve color. The color has changed. So we can make it faster. This is the fastest actually allowed in this simulation. It will go zoom, little less. Now let us try to remember the position of the object at equal intervals of time. For that we have this time axis. This controls the time. What do I mean? The same motion. Let us look at using this. So initially it is here. For this time simulation, the bigger circle has disappeared. The bigger circle I'm using as a line. It will be clear why I'm using a line instead of a big circle. So the blue dot, the function is same. The object is moving towards left. Now even the motion is not happening. We know looking at these colors, the object is on the right side of the reference and the blue color indicates that it is moving towards the left. Now let us take one time step. That is after 3.4 seconds, the object would be here. Initially it was here, now it will be here. Next 3.4 seconds from here. Similarly, equal steps. You can see the glow has changed. It has crossed over to the left side. What do we see? For equal step of time, the object covers same ground in this direction. Also, we can see in the smaller time steps. Let us see. So for a time step of 0.34 second, what happens? So this is for 0, this is for 0.34. Next 0.34 seconds, next one, and let me do it faster, and that would represent at equal intervals of 0.34 seconds. What do we observe? Whether it is 3.4 seconds or 0.34 seconds, the object covers same ground in one direction. So we can see parallel lines separated by same distance. So this is one kind of a motion. Or we can see the same thing happening towards the right. Let us put it on the left and the object moves towards the right. So the big circle is replaced with the lines so that they don't overlap.